Hi, I'm Charles, and welcome to part 16 of the OpenSCAD video series. In this part, we're going to talk about modules. So, in OpenSCAD, there are generally two types of modules. There are modules that create objects and modules that modify objects. And I guess there's a third type of that. If you combine those, you have modules that create objects as well as modify already existing objects. So I'm gonna go ahead and start showing how to create modules. So maybe I'll give an example, maybe you want a new shape. So let's start with a cube. Maybe you want to create a cross. 20. One. So we have a cube or a rectangular prism. We can copy this and we can just change the direction of one of them. So now we have a plus sign or a cross or an X, whatever you want to think about as we can add one more and get an orthogonal set of rectangular prisms. So now, if you wanted to create this shape a bunch of times, what you might have to do is you might end up copying and pasting this whole thing a bunch of times, which is really slow and cumbersome, and it will clog up your code and make things hard to read. So one of the main things that happens in programming and computer science is you want to reduce the amount of code that you have to write. You want to create modules or functions that allow you to generate your code much more easily. So I'm going to show you how to do this thing, which is this thing, in a modular and simple way. So first we're going to create we write module, and it's an orthogonal set of rectangular prisms or cubes, so we're going to call it ortho, and then we have parentheses, and then curly braces. So this part might be a tricky part. You have to figure out what you want to take as an input to your module, or it's kind of like a function, but it's not quite a function. It's called a module. So you have to give your parameters names. So you could have A, B, C, but for this, we only need just one input. And what that input is going to be, it's important to know what your inputs are. So we'll say input V, which is short for vector. So we're going to say V is a 3D vector, which means V has 3 inputs, just like these. So what we're going to do is we're going to say we can essentially copy and paste what we have here. But we're going to get rid of everything that's inside here. So we're going to replace it with our own variables. So we will say v0, which will be the first value of our vector, is equal to v0. v1 is equal to v1, which is the second, or the value at index 1 of our vector, and v2 is equal to v2. So now what we want to do, we look at what we've done here. So essentially what we've done is we've just moved our first one, our v0, over every time. We just moved it over, and we took this value and we popped it over, then we took this value and we popped it over. So we just moved our initial value through the list. So we can see we have 20, 20, 20. We're going to replace that with v0. And at this point, just to demonstrate how the module can be used, hopefully I'm not confusing anybody, but I'm going to finish this module in a moment. It's not quite done, but we can already get what we have so far. So the syntax for a module is similar to the syntax for any other object, specifically the ones that create objects. So we say ortho, parentheses, semicolon. Maybe let me just get rid of it so we see that nothing pops up because we've commented out what we had before. And now what we're going to do is we're going to put in our original first vector, which was 20, 1, 1. And so we get the same thing, but now with a module, this is much more versatile. I mean, we could put in 0 for these as well. It wouldn't have an effect, but we're going to change that in a moment. So just not to confuse anybody, I'm going to leave these as 21, 1. And we could change this to 30, and this will increase the length of the axes. So let me just show an interesting animation. So with this module, just this code. And if we wanted to define another one and translate it, we just do the same code. So as you can see, our code is generating this set or shape of orthogonal rectangular prisms. Orthogonal just means all 90 degrees to each other, in case that's not known. So you can see that the x, oh, I'm not looking at it the right way. The x is 90 degrees to the y, x is 90 degrees to the z, and y is 90 degrees to the x, and 90 degrees to the z. They're all 90 degrees from each other. That's the point. So I'm going to stop animating now. I'm going to take this away. Just end up with what we had before. So that's our set of orthogonal vectors. Now, if we wanted something maybe more custom, we need to actually add in the values that we've defined here. So we know that this is v1, and this is v2. And so what we do is we pop over v1, and v2 stays where it is for this one, and we pop over v2 because v1's already here, and now we just move over v2. So now this should give us the same thing, but if we change a value, we get an interesting new shape. As you can see, it has some interesting properties. It probably works best when they're square. But that's the gist of a module. So now that we just have this code, we can say we wanted a bunch of these objects. I'm going to take it back to 21.1, and I'm going to create a for loop. So now, instead of having to copy and paste our original code, we have a much more compact statement that's much more versatile than what we had before. So that is the power of modules. That's one of the reasons why they're so useful. You can reuse your code and call them in a simple way, which is just this with whatever parameters you have. So I'd say that's pretty convenient. So now let's look at modules that change objects that already exist. So you define them in the same way. With module. And we'll call this one scale. We don't want to do that, because if we called it scale, then it would overwrite the actual scale function, which is not what we want to do. So we'll just call it S for scale, for short. And let's say it takes one parameter times. And we need curly braces. So there's a new value. So there's this new value, and this new value is called children. So let me just give a quick example. Say we had rotate 1, 2, 3, and we had a cube. Then the cube is the child object of rotate. So in a module, a modifier module, whenever you have objects kind of underneath the object, and there goes the fire truck, they are the children. So if we had more than one object, by declaring curly braces, and you had a sphere, I'm not actually going to preview this because it's not super helpful to what we're doing. Hopefully you get the idea that these are both now child objects of rotate. So when it says children, it refers to these objects. So children, you can also index children. Whoops. So if you were to say children 0, that would just refer to cube. And if I said children 1, that would just refer to sphere. And this just means all the children. You can also, another important value is $children. And that is the number of children that you have in this under your module. So if you have 2, you have this value is 2. So let me just get to maybe I'll comment this out as opposed to getting rid of it, because it might be useful. So let's scale all the children under the module by times in 2 axes. So now that we've done that, why don't we test out our module? Let's create a cube. Size 10. And a sphere. Radius. Diameter of 12. And now let's apply our module to it. So we go S, parentheses, and we need a number for times, so let's do 2. So we see what that did. And the reason it only modified the cube is because the cube is the first object, so it thinks it only has one child object. So if we want both of them, there's two things we could do. We can put them in curly braces like this, and that will have the desired effect. Or we can union them, and that'll do the same thing, because then they're treated as one object. So it's probably the easier way to do it. So we can do 3. As we can see, we're scaling in the X and Y directions as we specified. And so maybe we could change this. We could change this to 1 over times. So when we change our module, our modified shape changes. So 0.5, get a couple interesting values. So when we play with it, we get different shapes. We can also do a difference. So we can say difference. This we might want to index child 0. In this case, the first child. And so that just takes away the object. And now we have a module that does a difference. See, we're modifying these. Scale 2, see what happens there. We get these interesting shapes. And we can always reverse the order to see what happens there. We get that. So these are modules that modify objects. That's really the basis. You can do an intersection as well. There you go. So you can use the modifiers and the operators that we've seen before inside modules. That's mostly the basis of modules. Don't forget, you can also have multiple values. You can have as many as you like as an input. We'll call this one input 2, and maybe we want to translate by input 2. and maybe that does something for us. Input 2, let's say 10, and as we can see, it moved by the amount we specified. So these are really the basics of modules. I'm trying to think if there's anything else that I should add to this. So I've thought of another thing. The other thing that you can do, I'm going to comment out this module. Is it creating anything? I don't see anything. Sometimes if that happens, you'll notice that the set of axes in the bottom left-hand corner disappeared. Let's see, right there, disappeared. So you want to increase the size of the screen until they reappear. It's just a bug. It comes along with the program. So the other thing that you could do is, if you have a bunch of objects superimposed, you can space them out. Get rid of this one. So, say we have a cube, sphere, and a cylinder. And I'll create values for each of these, so hopefully we can see them. Let me just, this cylinder should be appearing. Just not sure why it's not. Forgot a semicolon. That's it. Well, that does not help. So let me take this back down. 30 is a bit much. Okay, so we have all these objects, and maybe we want to space them out. 6 is probably a better diameter. So we can see them all. And say we want to create some module that will move them all. So let's create our module. Move. So I guess we could pick a spacing. Spacing. That's not how you spell spacing. That's how you spell spacing. So we can create a for loop. So we can say I equals 0 through the number of children minus 1. Because remember, with indices, they only go up to the number of elements that you have minus 1. So we create our for loop, and we can translate each of the child objects a certain amount. So we could translate them to the left, to the right, up, down, whatever. Let's say, we will say I times spacing. So we're going to do it in the X direction. It's just children I. So that compiles okay. And now we have to use our module. So nothing happened because there's no value in for here. It didn't give me a warning, but let's put a value in. Let's put 15 in. So you can see what it did there. It separated each of the objects. Now maybe if we wanted it to go from last to first, we could do $sign children minus 1 minus I. And that'll just switch the order of them. If you wanted to do that. So as I was saying before, you can also add objects. So at the beginning here, let's add an object. Let's add a cone, so a cylinder. The height will be 20. The first radius will be 3. Second radius will be 0. And the center will be false. So that adds an object. So we can add objects as well as modify them. Now I don't often have a good use for adding objects and modifying objects in the same module. It'd be interesting to see a good use for that. I don't know of any off the top of my head. Just because it's hard to create a general module for that. But again, we can use the variability of our module to increase the spacing just with the change of one value. So it can be very convenient and useful. And if we get rid of it, we can see what it goes back to. And we have no cone because our module didn't create one. So something I just want to talk about quickly are default values. So if I had no values in here, if you can think back to the earlier examples, you know that if we just type in cube without any parameters and a semicolon, then we get a cube, which means there have to be some default values in there that just automatically apply. So what I'm going to do is create default values. So right now it's kind of treating 0 as a default value, but maybe we like 15, so we just say spacing equals 15. And that becomes a default value. And then if we want to change it again, we just go spacing equals 30. And that changes it for us. But if we don't feel like defining it, we can always just use our default value. Say we wanted another one. It can be height or h. Say height equals 18, and maybe we want to translate the cylinder up 18, or our default value, or whatnot. So if we use our default values, that happens. We can just define height, or we could just define spacing. height is 0, and that brings that back down. And we can also define them in different orders because we're defining them by their names. Spacing equals 10. So that's a few things you can do. These can also be done in modules that, where is it? Here, this sort of module that creates objects. These same sorts of things can be done. Except for children. Children is pretty unique to modules that modify objects. A key difference in the syntax is if you have a module that modifies a shape, like move, then it doesn't have a semicolon after it. It doesn't need to. I could just do this. But then it just treats the cube as the child object, only one child object. So that's why I have the curly braces. So that's mostly it for modules. To really learn how they work well, I encourage you to play with them and test it out for yourself. That's the best way to get an idea of how they work. Also, referencing the documentation is a good thing. So thank you for watching, and hopefully I will see you in the next one.